angle, side, angle, and we've got angle, angle, side to prove that triangles are congruent. So these are going to be our end games for the proofs that we're going to do right now in notes. So for our first proof, let's go ahead and get our T-chart set up since it's not there for us. So T-chart, if you want to be lazy about it, just put a S and an R, statements on the left, reasons on the right. A proof should never, ever, ever be blank because we are all capable of doing what? The given, whether you want to be lazy about it. I'm going to actually write it down. Feel free to do the same or just put given across. So they give us that angle S is congruent to angle Q. What's nice about this diagram, they have everything marked for us. So S is congruent to Q. Okay.
Whoa, you're not understanding.
So that's an angle congruent to an angle, right? Angle congruent to an angle. All right. What else do they give us in the given? They say that RP bisects angle SRQ. It's given. All right. Red flag. Bisects. Woo, woo, woo. Okay, I got two options for bisect. I got a segment bisector, or I have an angle bisector. Which one is this one talking about? It's an angle bisector, right? It's bisecting an angle. So what does an angle bisector get us? Two congruent angles. Where are those two congruent angles? They already have them marked for us, which is nice. If you can't see it, if you think about angle SRQ, it's this whole entire angle. Split it in half. You get that side and that side. So what would that congruent statement look like on the left? Angle what's congruent to angle what? Yeah, yep, you guys got it. So angle SRP is congruent to angle QRP. And we're going to say, oops, that should say 2, not a 1. If angle bisector, then 2 congruent angles. Okay. So now I got another set of angles. I got an angle and an angle. There is no angle, angle, angle. That means I need to get a side somewhere in there. This one has really blinking lights saying, put me down, put me down. Which one is it? Reflexive, right? Reflexive. Is it PR and then RP, or is it PR and PR? Yeah, it's the same thing. So don't flip it. So whether you do RP or PR, that's up to you. PR is congruent to itself. Reflexive property. So now I have one congruent statement. I have a second congruent statement. I have a third congruent statement, which is what I need because this is definitely not hypotenuse leg. There's no right angle, which only needs 2. So I have 3. So now it's my end game.
Is it angle, angle, side?
It is angle, angle, side. Michaela, why did you pick that one instead of angle, side, angle?
Because angle, side, angle would be 2 angles. It would mean that S and R and Q.
Right. So we would need to have SR and Q and R be the congruent side for it to be angle, side, angle. You're exactly right. So this is an angle, angle, side congruence. Done. Okay. Pat.
For the second one,
Yes.
would you not be allowed to do that though because you're writing down what you have to prove? Oh, I know that's angle.
Yeah. Yeah. We're eventually going to get to where we're going to have something that with the angles, but we're not there yet. All right, flip on to the back after you have that one. Go ahead and get your T-chart set up. Sure. All right, so let's see. Oops, come back. Statements on the left, reasons on the right, and the given. If you want to be lazy and just shoot it straight across, feel free, but I'm going to write it down. So they tell us that XQ, what does that symbol mean? Parallel. Okay, we got parallel lines. So that means I'm going to be probably doing something with this statement. What do parallel lines give us? Alternate interior angles that are congruent. Okay, let's hold on to that thought. It also tells us that XR bisects QT. All right, so bisecting, I've got two options. Is it going to be the angle bisector, or is it going to be the segment bisector? It is a segment. Jimmy, why? Right, so it's bisecting a segment. There's no angle in there that's bisecting. Okay, so that means I'm going to get two congruent segments from that. So let's go ahead and mark up the diagram. Where are going to be the alternate interior angles? Now to make our lives easier, don't put this on your paper, just watch. I'm going to put 1, 2, 3, and then a 4. Those would be all the outside angles. If I extend the parallel lines like this, and I make QT be the transversal, which two angles would be the alternate interior angles? Does everybody see how 2 and 3 would be the alternate interior angles? Go ahead.
Those. Okay, nothing. I don't know. The
Okay.
M, aren't those vertical angles?
Yes, we do have those too. This one has very many different ways that we could do it. So we could do that, the 1 and 2, so this angle Q and that angle T could be congruent to each other. But what if I did the other way and made this be my transversal? Do we have other alternate interior angles? Yeah, we have X down with R. Let me get rid of these lines again. So we have X congruent with R. Okay, Michaela just said about vertical angles. So we know that those are going to be congruent. We don't have an angle, so that doesn't work. Bisecting, so if XR bisects QT, that means QT is cut in half. So where are my congruent segments from the segment bisector? Yes, TM is congruent with QM. All right, now let's look at this diagram. We've got so many options to work with. Let's pick which one we think we want to go with. We could ignore this and do what? Theorem. Angle, side, angle. I could ignore that. I could ignore this angle and get angle, angle, side. I could ignore the vertical angles and get angle, angle, side. Okay, so we need to pick one. So there's really 3 different ways to prove this. Let's pick one of them. Personally, I would like to just do some ditto marks. So if I wanted to do a ditto mark, that means I would have a duplicate of 2 things. What 2 angles are technically the same reason statement? So which one? It would be angle, angle, side, and it would be using alternate interior, right? Does everybody see how that would be the easiest to just do ditto marks? So if we ignore the vertical angles, let's go ahead and get our alternate interior in there. All right, so angle, I'm going to do 3 letters. MTR is congruent to angle up here. If I go MTR, then it will be MQX. If parallel lines, then alt interior angles congruent. Now let's do the other set. Line 3. So I could name this angle MXQ.
Can't we just put it on the same thing?
You can. Technically you should have that many lines, but if you want to put a comma, do it, that's fine. Angle MXQ is congruent to angle MRT. And ditto marks. All right, the last thing we need is a side. Give me the congruent statement for the side. Yes, so TM is congruent to QM. So line 4, if segment bisector, then 2 congruent segments, then we have it. So we would prove that with angle, angle, side. These I think are the hardest ones because you got a lot of options on what to go with. So triangle XMQ is congruent to triangle RMT. Okay, I promise. Proofs are probably the hardest thing that you are going to do in geometry class. So you need to get yourself through the proofs, and I promise the rest of the world of geometry will not be as tedious. Okay, everyone hates proofs. If you would ask your parents what they remember about geometry, they would probably say proofs, because everyone just hates proofs. But for some reason, that's what you remember doing in geometry. You just remember doing proofs probably because you hated them so much. My goal is to try to make them the least amount of hate that you would have towards them by making shortcuts on how we can abbreviate things and not having to write everything out, and going from there. Okay? All right. So